Hi, I'm Jenny.
Hi, I'm Nicey.
Hi, I'm Adriana, and we are the Climate Jenga. We want to recognize another team member, Ginty, who had to drop for personal reasons.
Our climate is like a delicately balanced structure of Jenga. Each block represents a parameter: temperature, water, rain, snow, carbon, and humans, amongst others. Like our climate, each block is important, and all of these blocks are interdependent. The structure will inevitably collapse if too many blocks are removed, but in this game of climate, there is a slight change of rules. You can add the blocks back into the structure to strengthen the foundation. That rule represents our conservation efforts, which help to restore the planet's balance. Keeping this metaphor in mind, let's look at our climate Jenga. The NFS manages 193 million acres of land across the US and must prioritize where to focus climate change prevention and mitigation efforts, especially given the increase in climate-related disasters. Using data from the Climate Risk Viewer, our research aims to pinpoint areas with the highest climate change risk and ecological importance. This analysis directly aids decision-making for the Forest Service to focus conservation efforts.
Right, now we're going to talk about our data methods. We focused our analysis on just the US federal lands within the contiguous United States, where the National Forest Service can quickly implement climate adaptation strategies. Next, we categorize these layers into either risk or importance clusters, where we considered risk as layers that displayed a future impact associated with different climate change factors or our Jenga blocks. We considered importance as layers that show the opportunities to improve or protect certain areas in terms of livelihoods, ecosystems, and the climate. Out of the dataset, we used 5 representative risk layers and 3 importance layers. Now, given that each layers had a different number of predefined categories, we reclassified and normalized the data so all the layers had ranks between 1 and 5, ranging from minimal to extreme risk or minimal to extreme importance. All data layers are rated equally, so no layer contributes more to the score than any other. Next, once each layer was normalized, we took a sum of individual ranks across the layers, resulting in one total risk layer and one total importance layer. We decided to set the values for rows with missing data to 0. Now we have data from all different scales accounted for. Then, for each layer, we decided on a cutoff score to determine whether a risk or importance was high based on the highest rank of 5 occurring across more than half of the total layers. For example, considering 5 total layers of risk, if 3 layers have a value of 5, it generates a cutoff score of 15. Lastly, we combined and overlaid these high risk and high importance layers to visualize the areas deserving priority for the National Forest Service climate mitigation strategies. Now, let's take a look at what we gleaned from our analysis.
This map shows the high-risk layer in red, overlaid with the high-importance layer in purple. The National Forest Service may use this map to prioritize conservation efforts. Our analysis shows that 71% of the federal lands are at high risk. Of those high-risk areas, 5% are both high risk and high importance. And this accounts for a total of 14.5 million acres of federal lands. Then, go to our recommendations. The scores and maps that we generated help the Forest Service identify where climate mitigation strategies will have the greatest impact. They also provide a baseline to begin tracking how climate risks change over time within these areas. To meet the goal to conserve 30% of lands and waters by 2030, outlined in the Conserving and Restoring America the Beautiful report, the National Forest Service can use this approach to prioritize high risk and high importance areas. The geographical extent of analysis must be extended to tribal lands and state and local government lands, as outlined in the Climate Adaptation Plan. More layers can be added and categorized to risk and importance categories to account for additional Jenga blocks contribute to the climate. Thank you for your time.
Thank you.